In this section of our chapter, we're going to be looking into new discoveries and incorporating these new discoveries into how the solar system model came to be. Please make sure that you have a highlighter or something to write with. So let's begin. Please follow along and highlight with me as we go over these new discoveries. It says, despite the widespread acceptance of the geocentric model, astronomers continued to gather data and refine the model. Remember in our earlier section, the geocentric model was basically saying that we, in fact, the Earth was the center of the universe and the center of our solar system, and everything else orbited around the Earth. That was called the geocentric model. So the geocentric, to review, was the Earth as the center. So now we're looking into another model here. It says, many Indian and Arab astronomers made great advances in mathematical models that explain the movements of objects in the solar system. In 1543, a scientist named Nicholas Copernicus, I'm sure that name rings a bell, used their calculations to propose a new model of the solar system, one with the sun at the center. Cooper's heliocentric, let's highlight that or circle that, heliocentric, has the sun in the center. This sun-centered model explained retrograde motion in a simpler way. It relied on the sun being at the center and the planets arranged around the sun based on how quickly each planet orbits the sun. So take a minute now to answer number 11. Why might scientists favor Copernicus's heliocentric model over Ptolemy's geocentric model? And remember, geocentric, the Earth was in the middle. Heliocentric, the sun was in the middle. Helio means sun. Most astronomers believed that the heliocentric made sense and was simple, and scientists were always looking for simple explanations. Please add to your answer that it is simple and made sense. Revising and expanding the model. Danish scientists in the 1500s, Tycho Brahe, built huge instruments that allowed him to take extremely precise measurements of the stars and the planets. His assistant, Johann Kepler, used Brahe's data to calculate the shapes of planetary orbits by suggesting that planets have elliptical or oval-shaped orbits rather than circular orbits. Kepler was able to explain complex planetary motions. These findings helped to convince scientists that Earth and the other planets revolve around the sun. So basically, guys, this was proof, and this is obviously the real belief and the real thing today that we know for sure that we do, in fact, orbit the sun, and the sun does not orbit Earth, nor do the other planets. So that was a big discovery back in the 1500s. New technology led to new discoveries. Just like today, as technology improves, so does what we understand about the world around us. It said, as Kepler was publishing his work, revolutionary technologies were being developed. In Italy, Galileo Galilei combined magnifying lens to make the telescope in 1609. If you remember, I did mention this, that Hans Lippershey was actually credited and should be credited with inventing the telescope because he was a glass maker and he basically made glasses that were strong enough to see very far distances. Sometimes we call that binoculars or a telescope, but what Galileo did, which was different, was he used it to study the sky. So it says a telescope is an instrument that collects and concentrates light from distant objects to make the objects appear larger and brighter. Early telescopes magnified objects only by 3 to 30 times, but that small amount had a huge effect on astronomy. Galileo's observations through his telescope revealed details of planets and moons and changed centuries of scientific thought. So for hundreds of years they thought one thing, and now these discoveries are changing everything they know. He noticed that the surface of the Earth's moon was rugged, not smooth. He observed sunspots on the sun and identified the phases of Venus. He also saw 4 small objects moving around Jupiter. This was a big discovery. These moons of Jupiter would finally prove that objects could orbit bodies other than Earth. If you look down here, these are the names of the moons. It's Callisto, Ganymede, Europa, and Io. And these are actually referred to as the Galilean moons because he discovered them, so they should have his name. Obviously, we know now that Jupiter has over 60 plus moons, but at the time, all they could see with the technology that they had were these 4. So they became known as the Galilean moons. Number 12 asks you to look at the diagram of these moons. Up here they're labeled with their colors, and they want you to look at which object appeared to move the fastest, looking at those 4 moons. Which object appeared to move the slowest? Explain your reasoning. Take a minute to answer number 12. If you noticed correctly, you would have seen that Io moves the fastest, about halfway around Jupiter each night. You can see Io there is the orange one, and then on the next night he's over here, and on the next night back over here, and on the next night over here, and so on and so forth until the end of the 5 nights. Callisto moves the slowest. Turn now to page 92, and we're going to look at a growing family of objects. It says advancements in telescopes occurred quickly over the next 300 to 400 years. Each advancement allowed scientists to see farther or with greater clarity and detail. Scientists collected data and used mathematical modeling to discover and describe new planets, moons, and numerous smaller objects within the solar system. Mathematical models predicted that planets would exist beyond the orbit of Saturn, Mars, and Jupiter. So remember, up to this point, we only thought that up to Saturn was the furthest planet. So we hadn't discovered Uranus or Neptune or Pluto or any other object. So this was a big deal. In 1871, the planet Uranus was discovered beyond Saturn. In 1801, a small round object was discovered between the orbits of Mars and Jupiter. The object named Ceres was not a planet. Originally, Ceres was considered an asteroid. It was the first object identified in the asteroid belt and is now considered a dwarf planet. So once they came up with that definition of a dwarf planet, Ceres was changed from an asteroid to a dwarf planet, just like Pluto was changed from a planet to a dwarf planet. That didn't happen until 2006, though. The planet Neptune was discovered in 1846, and Pluto wasn't discovered until 1930. So you're talking about from the 1500s to 1930. So you're talking about a long time where they believed that there was only 5 planets or 6 planets until more were discovered with better technology, just like today. Today, both the ground-based telescopes, such as the South African Large Telescope, abbreviated SALT, and space telescopes, such as the Hubble Space Telescope, gather data that show distant galaxies, newly forming solar systems, and the birth and death of stars. Please take a minute to answer number 14 before we finish up. It says new technologies such as astrolabes, no, that would be telescopes, allowed astronomers to see dim or distant objects in space. The development of new technology is necessary to the advancement of science. Scientists must consider new evidence as they create explanations for observed phenomena. Taking a look at page 93, I want you to pay attention because these are all in order from largest to smallest. And I'm just going to highlight a few things that are important. We did go over a lot of this already: moons, dwarf planets, comets, asteroids, and meteoroids and meteors. So what I basically want you to know here is that moons orbit a larger body, such as a planet. They can even orbit a dwarf planet, an asteroid, but not the sun. Okay, so this is an important fact that it's not going to be orbiting the sun. Whereas dwarf planets, they can orbit the sun. They're usually spherical, but they don't have to be. That's why they say they're roughly spherical. And the big point here between a planet and a dwarf planet, as you know, is that they have not cleared their orbit. Okay, that was the distinguishing factor that we learned about recently about why Pluto was changed from a planet to a dwarf planet. Comets are like dirty snowballs, as we know, and as they get close to the sun, their tail starts to melt, that dirty snowball melts, and you'll see a long tail come out from it. Asteroids, on the other hand, are irregularly shaped. They often say they are potato shaped, and you can kind of see in the picture there, they kind of do look like a potato. And then finishing up at the bottom, we know that meteoroids are small. Sometimes it's debris from the beginning of our solar system. It could be a piece of a comet or an asteroid that falls off. And we know that when it hits the ground, when it comes through our atmosphere, it's a meteor. So the last thing I wanted you to do in this section is compare and categorize the solar system objects. So you're going to be looking at these examples here. Pay attention to their shape, their orbits, what they're orbited by if they have an object orbiting them, and if they clear their own orbit. You're going to take these bodies here and put them into categories, whether it's a planet, a dwarf planet, a moon, or an asteroid. Please take a minute to do that now. You're going to use these words over here or these names. So if you did it correctly, you would see that Mercury and Neptune were planets, Ceres and Pluto were dwarf planets, the moons were Phobos and Titan, and the asteroids were Ida and Vesta. And you can know that these first two are planets because they orbited the sun. So that was a clue there that Mercury and Neptune were the planets. Okay? The dwarf planets were the ones that do not clear their own orbit, and they orbit the sun. So that was Ceres, that was Pluto orbiting the sun but not clearing their orbit. Phobos and Titan also orbit the sun, okay, but they do not clear their own orbit, and they are irregularly shaped. So Ida and Vesta were the ones that were the asteroids. And I always think Ida is pretty cool because even though it's a small asteroid, it actually has a moon that orbits it, which is called Dactyl. And the last ones were Phobos, and that's because they orbited another body. So they orbited a planet or a dwarf planet. So that's kind of very significant, and this is what we're going to do for our left entry in class, is we're going to basically tell the difference between the objects, which is also what number 17 wants you to do. So think about that now, how you knew or sorted them into categories. Please put your answer there now. A few things you might have mentioned were that planets are round and clear their orbits, moons orbit other objects, not the sun, and maybe that asteroids are irregularly shaped. This is your section on new discoveries.